We use fingerprints all the time to unlock our phones, at airports, and anyone that's into TV shows know how much they are the worst nightmare for every criminal mastermind, capable of turning what seemed like the perfect crime into a lengthy prison sentence. But very few of us ever stop to ask what's really going on in those tiny lines on our fingertips. So let's start with the basics. A fingerprint is not just a mark you leave behind. It's a pattern formed by tiny raised ridges in your skin, called friction ridges. When you touch a surface, sweat and natural oils collect on those ridges and transfer the pattern onto whatever you touched. That trace is the fingerprint. The real story, though, is in the skin itself, and here's where it gets interesting. Fingerprints start forming before you're born. Early in fetal development, the skin on your fingers begins to grow faster than the tissue underneath it. With nowhere else to go, the skin buckles and folds, creating ridges. By the middle of pregnancy, the basic pattern on each finger is already set. From that moment on, the fingerprint will grow in size as you grow, but the pattern itself doesn't change. That means the fingerprints you have today are fundamentally the same ones you had as a baby. Okay, but if fingerprints form before birth, why doesn't everyone end up with the same ones? After all, identical twins share the same DNA, yet their fingerprints are different. The answer is a mix of genetics and chance. Your genes influence the general shape of a fingerprint, whether it becomes a loop, a whorl, or an arch. But the fine details, the tiny ridge endings, splits, and turns, are shaped by random physical forces in the womb. Things like pressure, movement, blood flow, and even tiny differences in growth timing. No two fingers experience those forces in exactly the same way. Not even your own 10 fingers. So yes, even your left and right thumb are completely different. Same person, same DNA, different fingerprints. People often say fingerprints are absolutely unique. Scientifically, we need to be a little careful with that wording. What researchers can say is this: there are no documented cases of two people having identical fingerprints. Not among millions of prints. Not even among identical twins. So, while science avoids claiming absolute uniqueness, fingerprints are treated as unique for all practical purposes. The odds of a random match are astronomically small. But fingerprints aren't just about identification. They actually serve a biological purpose. For a long time, scientists thought fingerprints existed mainly to improve grip, like the tread on a tire. It turns out that's only part of the story. The ridges help regulate moisture on your skin, preventing your fingers from becoming too slippery or too dry. They also enhance your sense of touch. As your fingers move across a surface, the ridges amplify tiny vibrations, making it easier for your brain to detect fine textures. That's why humans have such incredibly sensitive fingertips. And here's a fun fact. Humans aren't the only ones with fingerprints. Other species have them too, like koalas. They evolved fingerprint-like ridges independently from humans, a phenomenon called convergent evolution. Different species, same problem. Same solution. Strong grip and precise touch are just that useful. So fingerprints are more than lines on your fingers. They are formed before birth. They stay with you for life. They help you grip the world, and they help the world recognize you. Tiny details with a surprisingly big story. But just like me, you must have wondered, how did fingerprints become a thing in forensics? They didn't become forensic evidence overnight. People had noticed them for centuries. But it wasn't until the late 1800s that scientists proved two crucial things. Fingerprints don't change over time, and they can reliably distinguish one person from another. The real breakthrough came in 1892, when a woman named Francisca Rojas was convicted of murdering her 2 children in Argentina. A bloody fingerprint left at the crime scene matched her thumb exactly. And when confronted with the evidence, she confessed. This became the first known murder conviction based on fingerprint evidence, and it changed policing forever. From that point on, fingerprints quickly replaced older, less reliable identification methods and became a cornerstone of modern forensic science. Fingerprints are obviously incredibly useful for catching criminals, which raises an obvious question. Can fingerprints be removed or avoided? So, can you get rid of your fingerprints? In short, not easily, and usually not permanently. Superficial damage like sanding, cutting, or burning the fingertips often fails because fingerprints are anchored in deeper layers of the skin. As long as that underlying structure remains intact, the ridges tend to grow back in their original pattern. Only deep injuries that cause scarring can permanently alter a fingerprint, and even then, the scar itself becomes a new identifying feature. Interestingly, a very small number of people are born without fingerprints at all, due to a rare genetic condition called adermatoglyphia. It doesn't affect health, but it can cause real-world problems in a world built around biometric identification. For everyone else, fingerprints are remarkably stubborn, and once you have them, they're pretty much for life. So, now you know. I hope you enjoyed this episode. If there's a question you've always wondered about, big or small, leave it in the comments. We just might cover it next time. And if you're anything like me, you probably wonder about a lot of things. Why things are the way they are, why we use the words we do, and where they actually come from. That curiosity is exactly why I wrote a book called Why Is It Called That? The Origins of Everyday Words. For example, why do we call the endless flow of moments time? The English word time comes from Old English tima, meaning a limited span or a season, but its deeper roots trace back to Proto-Germanic timon, meaning to divide, to cut apart. You see, our ancestors didn't see time as a flowing river. They saw it as something that could be sliced into manageable pieces, breaking the infinite into something knowable. If you'd like to explore stories like this, the origins of more than 350 everyday words, you'll find them all in my book. I'll leave a link in the description. Until next time, now you know.